We're surrounded by digital images every single day. But have you ever stopped to think about what a computer actually sees when it looks at a photo? I can tell you, it's not a dog or a sunset. It's something completely different. Okay, so take a look at this. To you and me, it's obvious, right? It's a dog. Your brain just gets it instantly. You see the fur, the ears, the nose, and it all just clicks into place. It's totally effortless for us. But what about the machine you're watching this on right now? To your computer, this picture is not a dog, not even close. It's something else. And that's the mystery we're about to unravel. So to get to the bottom of this, the first thing you need to know is that a computer doesn't see a whole picture at once. Nope, it sees a grid, a very, very organized grid. And that's really the big secret right there. Every single digital image, no matter how complex it looks, is just a grid of tiny little dots. Think of it like a piece of graph paper with rows and columns where every square is filled with a specific color. And what's cool is we can actually ask the computer to describe this grid for us. With a simple line of code, we ask for the image's shape, and it spits back these three numbers, 32, 32, and 3. So that tells us our grid is 32 dots high and 32 dots wide. But, what do we call those little dots? Well, they're called pixels. Each one of those tiny squares of color is a single pixel. They are, quite literally, the basic building blocks of every single digital picture you've ever laid eyes on. Okay, so we've got a 32 by 32 grid of pixels. That makes sense. But what about that third number? That 3 at the end. What's that all about? Now this is where things get really interesting. See, that 3 is the key to everything. It's how a computer understands color. Because remember, it doesn't see brown or gold like we do. It just sees numbers. That little number 3 tells us that for every single pixel in that grid, there's a set of 3 numbers that define its color. It's like a specific recipe, telling the computer exactly what color that one tiny dot should be. So what's in this 3-number recipe? Well, it's something you've probably heard of, RGB, red, green, and blue. Every single color you see on your screen right now is just some combination of those 3 colors. And those 3 numbers? They just tell the computer how much red, how much green, and how much blue to mix together. Let's test it out. We can zoom way, way in on one specific pixel. How about right on the tip of the dog's nose? We can ask the computer for its color recipe. And it doesn't say dark brown. Nope, it just gives us back 3 numbers, 6, 3, and 0. And that's it. That list of numbers is the color. It means a value of 6 for red, 3 for green, and absolutely 0 for blue. It's a super precise recipe that creates that exact shade of brown we see on the dog's nose. Okay, so this leads us to a really, really powerful idea. If an image is just a big grid of numbers, well, what happens if we start messing with those numbers? I mean, this is basically the foundation of all photo editing. When you use a filter or adjust brightness, you're not painting on a picture. You're just doing math on a huge grid of numbers. So let's try it ourselves. All right, with this single line of code, we're going to pinpoint one tiny pixel right near the dog's eye, and we're going to change its color recipe to 255, 255, 255. Just so you know, those are the highest possible values you can have for red, green, and blue. And boom, there's the result. When you mix the maximum amount of red, green, and blue light, you get pure white. We just literally hacked the image. We changed how it looks just by editing 3 little numbers in a giant sea of data. Okay, that was fun, but what if we go bigger? Instead of changing just one pixel, what if we do some math on every single pixel in the whole image? Let's say we take every red, green, and blue value and just divide each one by 2. And look at that. The whole image gets darker. By cutting every color value in half, we've basically dimmed the lights on the photo. This is exactly how the brightness slider works in your favorite photo app. It's all just math. All right, for one last trick. We've messed with the color values, right? But what if we kept all the numbers exactly the same, and instead, we just changed their position in the grid? The image rotates. See? We didn't click some rotate button. We just wrote a little bit of code to shuffle the data around, moving each pixel's numbers from its old spot to a new one. It looks like a complex visual change, but it's all just math. So look, this whole idea that images are just grids of numbers might seem kind of simple, but I'm telling you, Understanding this one concept is the key to unlocking some of the most powerful technology we have today. This is probably the most important thing to take away from all this. The fact that we can treat images as just another form of data, as numbers we can crunch and manipulate, that's the core idea behind the entire field of computer vision and modern AI. I mean, think about it. Those photo filters you love, they're just complex math equations running on that pixel grid. Facial recognition, that's just an AI looking for specific patterns of numbers that it's learned represent a face. A self-driving car sees the road as a constant stream of pixel grids, and it's analyzing all those numbers in real time to figure out where to go. All of it, it's all built on this one simple idea. And that leaves us with one last really fascinating question. We know a computer sees a grid of numbers. It sees the data. But can it ever really make that jump from seeing the numbers to truly understanding the concept of a dog? Well, answering that question, that's the big challenge at the very frontier of artificial intelligence today.